This assignment is for CPSC2100. This is coding problem set 3, problem 3. We're going to be finishing up that set with this video. So to start, we're going to use our balance, which is 5,000. So it's what we've been asked to use for that variable for each problem. And then our 18% interest rate, annual interest rate. And now we're going to set a higher bound, which is the balance multiplied by 1 plus the annual rate. So essentially what that is that is the balance multiplied by itself plus 0.18. So it's 1.18 times the balance. And then to figure out monthly payment boundary on that, you divide that by 12. Now we're going to establish the lower boundary. It's the balance divided by 12, because that would be the lowest amount that you could use to pay that off without interest. We're going to start with a while. While loop. While true, the total count will add in total by 1 each time. Now I see we need to add our total count variable. We're going to establish that at 0 to start with. So if the total count is greater than 12, well, we're going to say, let's go 30. We'll go through 30 iterations possible before we break. And now we're going to set up some variables inside the loops, so that we don't affect our global variables. These will just change in the loop as it iterates over new iterations. So new balance is just going to be balance. That's what it's going to come in at every time. And the payment is going to be the lower plus the higher, and that's divided by 2. So that's an average of the lower and higher bounds. And then we're going to go into our for loop. So for each month in the range 1 to 13, which is 12 months in the year, the new balance will subtract and total the payment to itself. It will also add the interest gained. So the interest gained is going to be the new balance times the annual rate divided by 12. And at this point, it doesn't really ask for this, but I like to do it because it does show you the iterations. The video on the assignment link was really helpful in that way. I like seeing that, how it kind of worked through everything. And we're going to start by printing these variables. The lower boundary, the higher boundary, the payment, and the remaining balance. That's going to be new balance. For each of these, we're going to go ahead and round those so they just don't look ugly. Too ugly in there, too many decimals. We're going to round it to 2 places. Okay, there we go. Let's see, we got an error there. Missing something. Is that corrected? Parentheses was not closed. Okay, well, we're going to finish this coding and then we'll come back to that. So now we're going into our if statements. If -1 is less than or equal to the new balance, and the new balance is less than or equal to 1, then we will print the lowest payment. Okay. And basically what that's saying is that if the payment gets down to, which I'm actually going to change that. I'm going to change that to 0.1. Let's see how that works. And then we'll break because at that point we've reached our lowest payment. And then else if the new balance is greater than 1, then we're going to assign that newly calculated payment value to the lower variable. And if the new balance is less than 1, then we're going to assign the new payment calculated to the higher variable. Okay. Run that. Okay, that was my error. There we go. Now let's try to run this and see what happens. Looks like it's saying I forgot a comma somewhere. Okay, lower comma, comma, comma. Boom. Right there. Okay, now let's see if it'll run. Okay, looks like it ran, and it printed out the iterations just like I wanted it to. So it can show you kind of like how everything shifts. It gives you each one of these values as it goes down the iterations, and as you can see, only one of them changes per round, depended on the logic that we provided for it. So right here it went negative, so since the new balance is less than 1, and in fact, I need to put -1. That's what we need to do, because that's still just going to, that'll be accurate up to $1. You'll pay your balance off up to $1. So we can go negative on this. So let's run this one more time. There we go. Okay. So, yeah, basically it shows your lower boundary, your higher boundary, your payment that it calculated for you to be able to pay your balance off. The remaining balance, though, would be negative 33.64. So that's not within negative $1 or $1. But since it is less than -1, it has been assigned, the payment value here has been assigned to the higher boundary value. So as you can see, the next time this payment amount moved down here to higher. And it'll do that for each time depending on what happens. It looks like there's a lot more lower boundary movement than there is higher boundary movement. Looks like you've got two times where the higher boundary shifts before the loop breaks. And you've got 6 times where the lower boundary shifts before the loop breaks. But yeah, the lowest payment that I could calculate was $451.68 to pay the total off, and that is the lowest payment amount that you can go in order to pay this balance off in a year.